like I'm trying to build a better.
Your contributor.
No, I will probably so you know what a build system is? You're from okay. Do you know Kacking, the workspace you use?
Oh yeah.
So essentially, I think package management system is really shit, and I want to build a new one.
In the bond.
No. It's his personal project. Okay,
Oh,
so
yes.
yeah, so we are here physically. No, just recording for. No. You don't have to be like. Actually, I can tell upwards. So maybe a quick introduction. I'm Hui. Yes, you might know me. Then
Wait, what is this for?
for those who cannot.
Oh, okay,
Yeah,
okay. We should show our face though.
Okay,
Wouldn't
yeah,
it
right,
be
correct.
Hi,
Sorry.
I'm JX from McGill University, Canada.
Sorry, you should continue. Sorry.
Okay.
I'm Jiyu and I'm from Triple E. Yichun from SCSU.
Okay. Yep. So for those who have missed, I think this week is the week where we start doing things physically, because that is like the best way to get things rolling. We can hypothesize a lot, but without doing much, then we don't have anything to show basically. So at the moment, I will just let this play and record whatever we are talking, I guess, because there is no agenda. So that's why we really encourage you to go down and discuss, because it is more natural and organic that way. It is not about me telling you what to do or like giving directive. I mean, we can shape our direction in a certain way, but most of the discussion and it will come up organically. I'm sorry. Yeah, so we'll just leave the microphone here. Probably we'll be doing something on the computers, but screen recording them is very troublesome, so you might not be able to see. So therefore you should come down. Yeah, okay. We just leave it here. All right. So yes, so we just had the PC to run our own ROS version, whatever that we want. So at the moment, I set up this is 2004. So this is for Noetic, but then we still need a worse version, melodic. So what
is it necessary to use melodic?
Because we want to try to be as close to the baseline and the environment that they shared with us. Melodic, yeah. Because I know that you're very excited about ROS in general, but I think
ROS is just really shit.
but at a starting point, we should stick to the environment, the thing that is constant. We try to keep it constant. The thing that we want to change is the algorithm, so we focus on that first. So here in the computer, yeah, they're all connected. I might need to like reinstall everything and directly install the 18 Ubuntu 18, because at the moment I'm using VM. Another middleman here to get the thing running, and it is not the best, it's not the ideal, because even though I try to put the maximum resources onto the VM, of course the VM will still have it run it quite slow. Right, it works, but not as fast. So you can see that the frame rate is 8 frames per second.
Oh no.
So real time factor is like half of what is the real time.
Hey, it's doing pretty well.
So this is running the default algorithm.
I'm genuinely impressed. You even got a VM to work. I've not gotten a VM working for ROS1 ever. It just constantly breaks.
Breaks is in the runtime breaks or the environment?
Oh, like just doesn't load that up.
Oh,
like it doesn't matter which computer it is.
Yeah, I don't know why, but okay. So this is what I set up, and as I was setting up, I thought that okay, since I'm setting up and I'm waiting for the thing to run, then I might as well just voice over and share what we had. So share. Oh wait, so here, so MLDA has a channel, and then I just upload.
It's got YouTube energy.
And then we just upload the two videos on the setup of the ROS for the bond challenge. So if you want, you can go on to, I will share in the group as well. You go onto the setup and then see how it is done. And maybe if you have a spare computer, you can try and make it work. Yeah, that is for the YouTube thing. Yeah, so the setup can be quite quick. Quick as in like less than 1 hour. So what so what you see just now is like the 8 frames per second, right? 8 frames per second, and the real time factor is like half, which we don't want, right? We don't want.
Yeah, I've written a script to set up ROS completely from scratch.
Yes, but we. Well,
I could have sent it to you.
Shouldn't the pseudo app thingy the
No, you wish.
Okay.
No, that's not.
So the CPU
fucked up.
the CPU for this computer.
Oh no,
is the
I
monitor.
unpublished it.
It's the monitor resources. Yeah, so somehow okay, in this hidden here. Okay, so this is the main. So this is the main OS. This is a VM. They are running from the same PC, but it's just different monitor. So the PC is from a server, Xeon. So it should have like 36 cores, but somehow I don't know why. But then 20 of that is like disabled, so it's left 16.
Yeah, because you're not using.
No, it's not using, but it's not even running. It's not running at 0.
It's probably CUDA settings.
Yeah, like it is very low. I don't know. Okay, but then for the VM, it is only using 12.
Yeah, because when you set up VM, you have to give it the number.
Yes. I did. Did I?
Yeah. Like in the beginning, you have to set how many RAMs, how
Yes.
much resources you can.
Yes, I did.
Are you sure? Okay.
Let's check.
Yeah, we should start a YouTube channel, guys. Can we?
You can.
Yes.
Well, shit.
So you
Oh no! It's recording.
We are now.
Never mind. Easy.
Yeah, we should make this into a vlog afterwards. Well, what's the YouTube version? Vlog?
A day in life. Edits. Memory processor 12. Okay. How do I? Well, yeah, somehow you cannot. Wait, hold up. Yeah, but for this one, same thing. So this is my personal one because last time I was frustrated with the school, so might as well bring it up. So this one, because it is directly, I don't play game or anything, so I just reinstall a new version. So it is like empty and with just the.
You should even Windows.
I don't. I my laptop. So yeah, so this is like around 25, which is faster, much faster, but of course there still be some lag and delay. Therefore, I was expecting this to run much faster, but probably need to install directly instead of a VM. Yeah, so that is the current stage at the moment. Machine. Well, 32. Say. Oh, okay, good. Oh, okay. Can. Oh, the red is just a coloring. Hopefully it's.
Wait, so was it using After Effects?
Now I think it's all you using.
GG. Can I set up a Tailwind Tailscale server on this so I can remotely access this computer?
No. Tomorrow I will be having a clearance briefing on the security and stuff, and that is not.
No.
No.
Wait, what is there to secure? It's a.
No,
Into
but
the-
it's school thing. It's a
What?
cool thing. It's a school.
property.
Yeah, and cannot
Bruh.
misuse. Yeah. With great power comes with
There's no
Come-
power, bro. It just responsibilities.
responsibility, you know. Yeah, it's still very slow.
Yo, NTU is like the most has the most hackable system,
Yeah.
like the aircon system.
Yeah, so even when I push it up, it doesn't seem to work. So probably without the VM, removing the VM will improve the performance. So yeah, that is the current state that we have right now. Do you have any ideas or anything to? So what are your problems when trying to install
Because
or
my
set up?
RVs cannot connect to like the ROS core here.
Oh,
Uh,
but you get the
actually,
simulation running, right? But then it's just the
not-
RVs.
it just can't show the simulation.
Oh, so it's either or, is it?
No, the simulation is running. Yeah, because like got the benchmark and everything.
Yes.
Yeah, I'll bring my laptop here too.
Okay. But so the RVs cannot connect.
It connects, but it doesn't simulate.
It doesn't simulate.
Yeah, it doesn't show.
Oh,
Quick question.
In-
How
in-
long did it take you to set up ROS1 melodic?
It's quite fast, honestly.
yeah.
Okay.
Yeah, but there are dependencies that were missing. So it makes
Yes.
it short.
Oh, okay, okay.
Yeah.
Yeah,
Yeah, so that might be something.
wait, were there missing dependencies or?
Yeah,
Not-
you need to like include like every distribution. That's
Within
one you
that
can
the
use.
dependency.
Oh, okay, so
So it's not about
Okay.
missing. It's so let's say at the moment we're operating on this robot called Jackal.
yeah, yeah,
So when we import the Jackal files depends on more stuff,
yeah.
and the default
But
ROS
it
doesn't have that.
It
So
shouldn't be solved by Makefile already, no?
no, the make file will look in your computer.
Oh, you have to, okay.
Get it down, yes, you have to get it
that makes
down.
sense. Classic ROS. Yeah, I've done Jackal
This,
before, but no
uh,
Arctic.
at
Not Neotic.
robot
No,
model. Right. So should we record this down? So yeah, so the question now at the moment is, so yes, we have the visualization, but the next step when doing with ROS and robotics is how we inspect these things. So why you laugh?
Inspections. The word.
ROS topic this. Okay, move base. Right, ROS topic. Temperature range, move base, effort, interactive marker break, contract opening. No, suitable topic. No, not point cloud. Is it point?
What are you looking for?
For the topic for the LiDAR scan. LiDAR scan is
To ROS topic.
oh laser scan. Topic. Front scan, okay. Oh, no.
My one exactly looks like this.
Okay, this should be closing soon.
Wait, what? They have laser scan also?
Yeah, so the input is only the laser scan and what
It's
we
in later, no?
LiDAR, yeah, so LiDAR and it should be publishing in that
Wait, sorry, what's the difference between LiDAR and laser scan?
no, it's LiDAR is like laser. It's just LiDAR is we
Oh, okay,
usually
okay.
talk about the sensor,
Sure,
but
sure, okay.
yeah, it's just a class, like a class definition.
Okay.
Oh, camera depth, effort, move base, TF. Status error.
Alright.
No frame to transform from. Base link. Okay, there's no base link. TF. Oh, the world fixed frame is chassis base link. Yeah. But then LiDAR scan, how do we impose the laser scan?
It's on.
Huh?
Like laser scans on.
On. Oh,
Yeah,
what? What did I say?
unreliable.
Okay, so now why is it stopping?
Yeah, but it's so laggy.
But is it laggy or is it because stopping some error? Yeah, so probably. Oh, okay. base link. Base link is here. Base link is like the start position. Maybe we can also zoom here. On meeting. Okay, it is share screen. So yeah, so what we are saying just now is we need some way to inspect, and I'm not sure why the simulation stopped at the moment. So let's switch. Set the params. Jackal. The time is still ticking, but the thing is not running. Yeah. So first of all, what we need is first is to visualize, and then get write down some notes in order to get the LiDAR array and start processing.
Oh man.
Actually, it is quite it's somehow good that this visualization is slow, because it will automatically exit, right? So it is good that it is slow, so that we have time to inspect. Yeah, so just now what I did was the global option, instead of a map, we can put the chassis link. And then we can add TF to TF odometry. Wait, I thought odom is odometry. Yeah, odometry. Oh, odom is like the start, and now the wheels are like turning. You can add the robot model to overlay, right? Then when we can add laser scan, the topic is front scan, and we save the configuration. So next time when we launch, it will be very fast. Let's save out in the desktop. Barn dot vis. Right. So now the laser scan is like this. Yeah. So you can see, right? So this is the thing that we have to navigate through and find the path. Yep. So it seems like there might be a lot of gap, but then the robot has to discern which gap is traversable or feasible to go around. Yep. And this is just the instantaneous gap, right? Previously many teams also use, let's say, not visual, slam. So as it runs, it will build out a map. So if there's any backtracking, then it knows how to backtrack. That was one of the techniques that various teams use. It's not just instantaneously, but also to build out the map using the scan. Even though it will not get a perfect scan of the environment, it still allows the robot to know where to go if there's some error. Yeah. And let's see. Will it reset? Oh no, it doesn't reset, does it? Yeah, so the RViz doesn't reset. We have to reopen. Yeah, so every time we have to reopen in order for it to run properly. Yeah. So Obvious, laser scan, TF. So if you know about ROS, then ROS will expose us to all the topics. What we can do next is also understand the RQT graph. RQT graph. Yeah, so the RQT graph will show us all the various nodes that is being used. At the moment, the navigation is purely based on move base. Yeah. So when we open up node and topics, then we can see that there are much more topics that is exposed to us. We do topic all and even more. So the coordinates, right? The XYZ axis here is the TF topics. So basically Obvious is looking into the TF, and yeah, it is doing like localization, and it will move base and give the command directory command velocity command.
So can you go back to the previous page? The RQT.
Yeah,
Okay.
right. So at the moment,
Yeah.
move base
Yeah.
simple.
Yeah. Okay. I see.
Jackal. So the Jackal is the base robot.
Wait, so what's the difference between move base and simple and move base again?
Move base simple, move base command. So probably move base simple. So we publish a goal.
Yeah. That's
So I don't
that's
know.
orientation and velocity or acceleration. Yeah.
So
orientation and acceleration.
run.py down here, launch your navigation stack. MB dash go, yeah, MB dash go position. So we publish the go position.
Oh, so we don't even touch acceleration.
At the moment, I think we give them we give it the position.
Right.
Then acceleration or something is based on the
Wait,
the command.
the competition is based on speed or just avoidance level?
It is, so first you need to traverse without collision, but if you collide, instant disqualification.
Oh, disqualification.
No, not disqualification, but then that run is toasted. Yeah, if you collide, that run is gone. But then if two teams finish the same round, then they will judge on speed.
So to optimize just for like avoidance and then speed, right?
Yes.
Okay,
so yeah, so at the moment it just, what we have is publish the simple goal to this move base node, right? And then the move base node will mediate with other nodes to get the cost map, local cost map, and get some action. Yeah, so all of these are default behavior.
Yeah, that makes sense.
Yep. And in order to get those, we need the robot publisher and TF, like basically the helpers, the helper nodes and the helper topics. Yeah. So where do we go from here? It's also Zoom recorded as well, which is good. Okay. Yes. So do you have any input? I also didn't prepare much for today. So yeah, just a chill. I think, yeah. So after today, after we know that what we have, then you can give me your time, like when do you need to come here. So Thursday and Friday, I will not be here, but I can ask if any of the members are here, and then the person will tap you in, and I think I will, vouch for your presence here, because you need to do work or try or experiment. Yeah, like even though we are like student led, but we need to take accountability. But I think you're here for work, so no problem. Just like don't mind Bitcoin or something here.
Hey yo, wait, what's the GPU?
2080 only.
I'll try not to.
Yeah. What do you mean you try not to? You will not.
I'll try really hard to control my impulses.
Yes.
No promises.
Yep. Any interesting Bluetooth, tele-op, e-stop, gazebo, IMU data. Okay, so we can have IMU data, but at the moment I don't know how to, what is the topic to like visualize, right? Cool. This is not responding. Yeah, so this is one, like understanding how the thing works is one thing, but we can also manipulate the more files to give us a better view or a better, basically even though the competition only requires us to code out the algorithm during the development cycle, we need the quality of life improvement. So for example, the world, so Gazebo, in order to get this world, Gazebo needs a description file. I think it's Jekyll helper worlds. So in this world, they define all of the world here. So so it is an XML file. So it will be loaded in accordingly, right? So let's say just now one of the hot environment is 250. So this is one of the alteration that I think can be useful, is when we scroll down, you can see that camera name, user camera. So this is when it initialized the very first camera position. So let's need to reference. Okay, -2, 8, 10. Can you help me type down in the program? -2 space 8 space 10 space 0 1.57 and 3.14. Yeah, the pi.
What is this for again?
So yes, just the initial position of the camera.
Oh, okay.
Just yeah, quality of life helper. So later after this run,
Yeah.
then you will see the rationale. So that run should stop relatively soon. Gazebo will exit on N. Okay, so now if we do this again, then the initial position will be like directly a bird's eye view, which helps a lot, right? Like instead of like all the way back there. So yeah, so there are various quality of life like this that will help a lot. Similar to the Arvis. Arvis is just another inspection to quality of life tool. So at the moment when we load the Arvis, we have to do file open config and all the, no, this is the default. All of these troublesome thing, right? But later we can write a launch file in order to like directly go here. And
Yeah, I can write a launch file.
yes, and another interesting thing is also we can also integrate that into the Python, because that is what they have been using anyway.
What do you mean?
So like run.py, right?
Yeah.
Run.py, then they write the launch file,
Yeah.
and then just subprocess stuff. So it will pop up and get us there. Yeah. So I think what so now that we can see the LiDAR scan behavior, right? I now have a better idea, or like, you know, human intuitive idea of why the learning method fails. Because in this simulation, all the objects have curves and arcs. So probably the learning algorithm, you know, they saw, oh, objects is like curves and arcs. But in the real world, all the obstacles are like triangle. So it will show a different LiDAR signature. So that is why I think it fails. So even though people say that reinforcement learning allows the robot to adapt to various environments. Yeah. So even though people say that it allows the robot to adapt to various environments, this particular configuration that the competition gave us is like all-rounded obstacles. Yeah, hello, sorry. So it is still also recorded as well. So if you miss anything, then yeah, you can catch up. Okay, I hope so. Yeah, so at the moment we can get the thing running. So now the first step, or like the first step, is trying to probe and inspect what is happening. So just now we just pop up an obvious, and the only mode of perception is the laser scan. Laser scan topic front slash scan. And now that you have the visualization, you can see that the obstacles are like in curves. So just now I was hypothesizing why the reinforcement learning method fails, because probably it has only been seeing curve obstacles instead of like cardboards. Yeah. And you can see that like so I think one of the okay, if you recall, there was a team that tried to detect the gap, the gap between the LiDAR scan to see if it is a possible path to go through. And yeah, you can also see from the LiDAR scan that all the LiDAR scan are not connected, right? So
What do you mean?
the LiDAR scan are just like dots, discretized dot, and then when they fall on a certain surface, it looks connected, like close to each other. But because of the nature of LiDAR scan, like straight lines, there are places where it looks disconnect, but there's no path there. It's just disconnecting because of the obstacles. So that is why one of the team try to have some algorithm to distinguish which one is like a valid obstacles in a sense. No, sorry, a valid path forward. Yeah. So that is probably it. The front scan here, we just front scan robot model just for visualization. It doesn't need to be robot model. We just need the TF. TF stands for transformation, by the way, for the Zoom people. Yes. Yes, I think at the moment that is all I have. Do you have any input? Also, yeah, Joshua just came. The video on. I think the video is on. Yeah. Joshua just came. Is anyone in the Zoom? Is anyone in the Zoom? No. But I will record. Yeah, it helps to do the recordings. Yeah. So now what?
Now we turn off the Zoom and we get to work.
Wow.
Oh, wait, you suspect the problem is because the team of who are using RL fail because the obstacles they form are different in the reality. So is it possible we use them to
Oh, true. Yeah.
to generate the maps such that all the obstacles are actually jointed, but not just curves or dots? Then we might be able to train. Otherwise, seems like RL is not a good choice.
Yeah.
Yeah, it's like, why don't we just use like classical object avoidance, just do a point cloud on everything nearby and then see if there's anything. And we just estimate like the gap in between, we just go through the route instead of doing RL because it's very high variance.
Yes.
And if it's any bit out of distribution, then we're fine.
So that was yeah, what other people also observe. So RL good is like well trained on the data set only and in the simulation environment. One team tries to improve on that by having a decision tree. So having a recovery behavior. Yeah.
Oh yeah. It's over engineering.
And like you said, we can try to find some like classical or algorithmic schemes. So then the question is what kind of scheme? Yeah, you are saying you're using SLAM, right? SLAM?
Yeah,
Yeah.
but that's for the choice of RL. If we are not doing RL, I don't think that's necessary.
Wait, SLAM and RL, how does it?
I mean, because we use them to formulate the map first, the genome map. So if because you were mentioning about the problem of not identifying the real life obstacle as obstacle. I mean because the LiDAR will not be able to formulate the surrounding environment. I don't know how to describe it, but just we want to form a more general map of the surroundings. So like simulates looks more like a real life thing. Yeah.
I think in the simulation.
But we also realize that it's quite difficult to use the IO because all the other teams seem to fail. So maybe you shouldn't detect this way.
Yeah, I think we should just implement classical control for now and then see if we can improve it.
Technically, can we improve from last year's champions?
Yeah, automatically happen.
Yeah, they do.
Automatically.
So that was why I think that wait, that's
I mean, we have to be novel, right? Because
we can
because we're definitely going to win, and then afterwards we have to publish a paper, and they're like,
Yeah.
"Sir, how did you implement your algorithm?"
Ultimately.
Here's a reference there.
Yeah, we just like
just
we
equally-
took classes.
yeah, yeah, they do have
That's last year.
yeah, they do expose. I'm not
Wait, so okay, do they only take the run.py file, or they take the entire repo when they run it?
sure. Big test, update singularity, chain local map, run isolated.
Is our repo public or private?
It is public. We are seeing it.
No, like yours, ours.
Yeah, public.
But can other teams copy our algorithm?
I don't think they know about our existence.
Oh,
Yeah.
yeah, we just don't tell anyone.
So okay, wait, the paper. What the-
Yeah, why don't we just take the winner's paper and just improve upon it and see what could be done better?
Ah, shit, no, no.
Will the team be joining this year's the
Most
previous
probably, I
year?
think. I think
If we had a better optimization.
Because I feel like if we take the state of art, you can't beat like the latest research, right? Because there's literally optimization functions. So.
not loading. It's so sad.
Wait, what?
Nothing can transmit.
I think it was the KU something.
Yeah, cool.
Yeah.
Yeah, so
But most probably people would use it.
the motion to the thing. So similar, I think the idea is similar to the base DWA, right? The base DWA is about inflating the. So you have an obstacles, and they try to like inflate the boundary of the obstacles. So saying that like if you hit that boundary, then that is hard no. Then they will try to sample the different velocity of the robot and see if it hits that boundary. So here it is like instead of the boundary being outside, now the boundary is inside. So I think they will still do sampling, like sampling different curvatures and velocity. Yeah, basically sampling. But they check the collision like on the robot.
I
And
see.
so it, for example, it will sweep out a certain tube, collision tube, right? And then it will check, okay, like it will sweep out this kind of curve. And then I will check my LiDAR scan in that direction. So if the LiDAR scan is like larger than the tube swept out, then it's a valid tube.
Oh, that's a good. Yeah, that's a really good idea.
So I think what they comment is that it is better because the motion tube are computed with respect to the robot. There's no dependency between the localization and accuracy, right? Because the robot doesn't have the map of the environment. It will it's
Doesn't
slamming,
assume
right?
the map.
Right. It is slamming on the spot. But slamming, of course, there will be some drifting, right? And you need to, like, let's say, go back to the original point to get the slam correct. But now there's no going back. So every localization effort or slamming effort is still there are uncertainty. Yeah. So I think the approach is good.
What happens if they enter that?
They enter that. So here, right, because they are using motion tube, let's bring it up. Yeah, I think probably we should write a script to keep looping this thing, looping this whole thing so that we don't need to keep clicking this. This. Let's wait till, yeah, so it will swap out the tube, so the robot will align itself towards the goal, like, because it tends to go towards that goal, and then it will sample what tube is possible in front, but it doesn't like make any decision, right? It doesn't. So if there are two openings of that it can go, when after it swept the tube, and probably there is some cost assigned to it, right? There's some cost, like collision cost, but both tubes are both valid. They both have high cost, but then it will choose the one with slightly better cost, and then it will move in, and if it becomes a dead end, then it cannot recover, I think. Yeah, so now I think, so even though I read we read the window approach paper, right? I still don't know how it managed to get out of this. So for example, this is a dead end. How does it get out? It only gets out because it sees that, okay, there is no possible forward velocity. So at some point I have to go backwards. Oh, yeah, somehow, yeah. So at some point I have to like go back and forth. But it doesn't, let's say it doesn't decide, right? It doesn't decide, okay, this is a dead end. I should just go like retract back. I don't have to like wiggle around. I just need to go all the way back. So I think that is like the drawbacks of having just like one algorithm without any like decision tree, right? At the moment it's just sampling, where can I go in front or like backwards, but there's no, okay, what happened here? Yeah, so if it hits here, where to go next? This is a major challenge, right? So just now it was supposed to go straight, but the moment it slightly missed, then the whole thing missed. Yeah.
But does it keep the map of the
No, and the default implementation doesn't have any map. The default implementation, no map. It's just using the normal costs. Yeah. Yep. Bentech is the one with the backtracking, and there's also like a bounding box checking. Okay, bounding box checking. And this one team, yeah, this one team has like a traditional approach to path planning, or like a mobile robot in general. Like they have all of the package, like localization, obstacles, path planning, like even from the top, high level to down to low level. Yeah. And also exploration as well. Find empty passage around. Yeah, so as it goes, it will keep track of, okay, like there's this one opening on the right, this one opening on the left. So if I try the left and there's a dead end, probably I will backtrack and try the right one. But I think for in the real competition, right, the track is very obvious.
Oh,
It's just that don't collide. Like the task is just not to collide, but it's obvious. But you can see like in this gap, right? It can fit the robot, but when it turn a bit, it will know that it should be a dead end,
quite near.
right? So even though it is obvious from our perspective, looking at only the LiDAR, it might not be that obvious, probably. There could be tricks. Yeah. So if you like slightly knock on the box, then that is you fail the run. Yeah, and then I think they also mentioned from the paper, they also mentioned that final ranking is still decided by success rate and not speed. So as long as you're like
Yeah,
slow and steady, you win.
yeah,
basically.
just go super slow, man.
No, for simulation, you want both because simulation, I think it's the simulation round is
Yeah, but so later runs for example, every second, just arbitrary number every second. So the slower we go, the more times we can scan the environment, which means that the higher the likelihood we can like understand the environment. So if we go like 0.00001 meter per minute, then like we can just always
No,
get
I
perfect
think
understanding.
that is not a
We technically though, right?
It might be bad for.
Yeah, we just run like
No, but I
separate
think
computer.
I think there's an upper bound. There is an upper bound. So
Eight, right?
yeah, 8. So OT, so optimal time. So what they do is
Oh,
there is an
okay, okay.
optimal path,
Yeah,
and then they like okay, like you should complete within let's say lower than 8
8 what?
8 times the optimal the time
Yeah,
taken
but
by
that's arbitrary. Like, what does it mean optimal path?
they can measure like right. It's not that arbitrary. Like yes, there can be some
Sure.
slight overestimation or underestimation, but you know there should be around that. No, you cannot. Oh, all right, and then you are given 30 minutes. You are
Oh,
given
okay.
30 minutes to finish, let's say 6 times.
30.
Yeah, so in one course, there are 6 runs.
Oh,
And then you're given like 30 minutes to both like calibrate and do dry run. Like you can actually in one course you can do multiple times, more than 6. But when you say, okay, I want this run to be recorded, you have to tell the judge beforehand.
oh,
So
okay.
you can say that okay, this run is for dry run. Like we just check the parameter. Okay, the judge will just look at you and let it run. But the moment you say okay, now this is a real run, you can start timing. Then he will go in, and everything will happen in 30 minutes.
So there are 5 real ones.
Oh, 5. Sorry, 5. Yeah, 5 real run. 5 run with score, and then they will take the best 3. Yes, average the 6. Yeah. So take the best 3. Yes, take the best 3. So success and total is like 9 out of 9. But you have 5 scored runs, but they will take 3 the top 3 or the top 3. So for example, this team is like 6 out of 9 because the last one doesn't get anything. Yeah. While the cool one managed to get on 9 or 3 out of 5. So max score of 9 out of 9.
What happens in this code 3 if everyone fails so hard?
Huh?
Can we see the map for it?
I think they don't give.
How does he get the 91? The 91 is from where? Is it from like course 3?
Average time.
Because the 31 seems like corresponding to course 1
Huh.
and 56 course 2.
I don't know. Oh yeah, shit. It's not an average though, right? It's not I don't know.
Maybe X has the penalty. Or
Yeah, maybe.
Probably. So yeah. So where is the So last time, same, but that time different people doing. Yeah, this is the gap finding team. Then there's a team that does, yeah, reinforcement learning,
Which fail.
which score the highest in the
Simulation.
simulation, score the highest in simulation, but fail in the real run tempo. Yeah. Okay, and your point on like, okay, like, do we need to do anything new or just incremental? I think we can be incremental.
Yeah,
So-
we just copy this code.
So, yeah,
fork
so-
it. No, I'm serious. Like fork it and just
So this team, right? Yeah, they just take wholesale and then put a finite state machine.
yeah, okay.
The-
But
the-
that's stupid. Like this is just the DFA.
what is DFA?
Definite automata. Deterministic finite automata. DFA. So it's like a decision problem. So basically, it's like who's in computer stuff? Have you done theory?
I
of
study
computer?
state machine, but I don't know what the.
Oh, okay. So it's like this is like essentially algorithm for choosing. These are all the available paths. Essentially, it's like okay. If we choose some arbitrary node, so like imagine this is a graph. Essentially, we're saying it's like okay, so here are the things the robots can do and cannot do.
Yeah. So
Yeah.
the rest is yes deterministic.
Yeah.
This node can be stochastic because reinforcement learning. So it's only this node that is stochastic.
Yeah, but it doesn't matter. So basically, it's giving different choices.
Mhm.
Essentially, it's gonna pre-run through these. Like for every step it takes, it's gonna run through this entire DFA, and it's gonna end up with one of these nodes.
Yeah.
So every time it's like a decision tree, but like
Yeah.
they just made it really complicated looking. This could be expressed in a tree, essentially. That's what I'm saying.
Yes, but
Yeah.
I mean, but it helps because this is like they're describing a recovery behavior for the reinforcement learning. So it's something. It is something. It's not totally stupid. Okay, it's something.
I feel like they kind of just copy some research paper. Like, dude, how do we make this as complicated as possible? Okay, fine. We'll just do a tape-based Turing machine for this when we write our papers. Just like, oh look, we have this tape thing that goes.
No,
like-
but they also okay. Give them more credit. They also like check collision like ahead of time as well and model predictive
Okay.
control.
Can you send this paper to me again?
Yeah, on the drive.
It's on the drive.
Drive.
Oh, okay. Can you just fine,
I don't have Telegram here. It's like,
sure.
I'm not sure if the team has their own paper. I'm not sure.
This is their paper, no?
No, this is the This is a collective paper.
Oh, okay, okay.
So if we win something like we get here, we get like the second line.
Yo, guys, we can win this. Come on, let's do it. Let's do it. Right.
Second line.
Okay. I think the hardest part would be like the implementation part. Just like getting it to work is
Yeah.
like
So,
just experimenting with it. It's not.
Yeah.
trivial.
so that's why like when my prof say that okay, like when you do robotics, right?
Yeah.
The point that you need to get to is to get all the setup done,
Yeah, yeah, yeah.
reach
yeah,
the point where you
yeah,
can like
of course.
close the loop, like propose something and experiment,
Yeah,
propose
yeah,
again.
definitely.
Yeah.
I can ask some my friends at Tesla working on autonomous driving. and
Wow.
see how they're doing. I mean, we can just implement whatever they're doing.
Nah. No, but they have a do they have a different problem? So here is like a constrained space. Well,
but
the,
it's
the,
not
the road is also quite constrained, right? If you are
Yeah, exactly.
squeezing.
So we can figure out what's actually the state of art algorithm being used by people. Because there are lots of research papers saying like, oh, this is the best way, but like. it's
no,
not
but then
practical.
this one is only LiDAR.
Yeah.
Yeah.
And Tesla just cameras. It's even stupider.
No, but it's like yes, that we
Because
can
Elon
borrow,
Musk is like.
we can
cameras.
borrow something, but I think
Yeah.
the mode of perception is different. So maybe there's some technique that is not.
Yeah,
directly
I mean,
transferable.
come on, we can beat cameras with later.
Yeah,
Also, so they randomly place boxes or
I think there is a template, a certain template, not really random.
Okay.
But the organizer have already had a certain cost.
How are the sensors set up?
oh, just one.
What do you mean?
Only
Only
one?
Only one.
That's fun.
Sorry. And here up top. We have the transformation coordinate.
Wait, I have no. Just wait. Yeah, just Ross being stupid. Wait. So what about blind spots? Like for example,
Ah, there is a blind spot.
where is it again?
So the rear. So that's why people also
Ah.
localize. People also
Okay,
do
okay, that makes
localization
sense.
so that
Yeah.
it can backtrack.
Ah, okay, okay, okay.
So yeah, localization is important.
See. Yeah, that makes sense.
Yeah, there it is a. We can have the transformation.
It's like shit.
Yeah, somewhere here, somewhere. I think we can also disable them. So system frame. Oh, okay.
Can we not show the text? Oh. Can we just like disable the text or something?
Base link. Okay, so this is base. Text. I'm not sure. I don't think so, but I am using. Okay, I'm using. Odom Knapsack. No, not Knapsack. Rear. Right. Front laser. Okay, front laser. Front laser mount and front laser. Save. It's front chassis. Same thing. Right. Yeah. Now that we see as a person, right, it's also quite hard. Like, okay, where do I go here? Right, left or right? It's actually also quite hard. Then now I don't know why the algorithm is like going backwards.
Okay.
Yes. Okay. Okay. Constraint space constraint. I think the more constrained it is, the easier to have a path. So I think that's why the motion to people is good as well, because the motion to curve out a curve, and then if it keeps going in that way, then there is like a momentum in a sense, right? Because if not, then if every time step you have to like recalculate your velocity, then there will be a lot of jerk motion.
Well, can you give like a momentum? It's not like the real physics momentum, but the ideal momentum in the direction and give you reward. So
Wait, not the deep learning momentum. Not the
yeah,
deep-
I know, but could it do it without like machine learning? Is it possible to implement a momentum without?
Yeah, so the dynamic windows actually try to write down the motion, the equation of motion, but then I think they all stop at like velocity or acceleration. They didn't go to the dynamics of it. Mostly just acceleration. The momentum, just now I said, okay, probably the momentum is a wrong choice of word, but the idea that because it the motion tube like curves out a certain curvature, and it assumes that if I continues to go in this velocity, I will curve out that curvature. And
Maybe like prioritize
right,
the curvature.
and then in those tight space, right, if it can find a good curvature that to go around the corner, it will just keep doing that. So in a sense, there's no abrupt change in the velocity, like
That's
jerk,
right.
jerk, jerk, jerk. So my hypothesis, so that's why it is fast and
So like as
Also
long as there's
helps.
no obstacle, they can just follow along the path, right?
if there's no obstacle, then it's just go straight.
No, isn't
Yeah.
it? If there's no updated obstacle, they can just follow the curve.
No, they'll go.
Okay.
You can check there's a video like of this implementation.
Oh, there is.
Just scroll down to the reference. I think it's 9.
Oh, that means they're also quite fast.
Okay.
So you think?
Which year? Scroll down where?
To the reference to their paper, the KU
Oh.
person.
They implement. Discussed in their original paper. And inflation. Okay. 12. Clutter resilient.
Just search this thing. In Google. No, not scroll
no,
down.
no,
Yeah,
scroll.
just Google. Mean like just one of the links is a video and then implemented. It's EPFL.
One of the things.
No, it's in the first few links. One of the links.
FL.
Or just they publish.
So you just click on random link. I think it's like the top view.
PFL lab. Clutter. Swap, optical flow cooling.
I think it's just implementation. It's not their paper. You just click on the first one.
Switch to.
Yeah.
Oh wait. Oh, it's their own tube. YouTube. Oh yeah, no sound. Sorry.
It's fine.
Server. It's
So
a
we don't need
server.
sound.
Barn challenge. Oh, research paper specifically for the barn challenge. Does not collide obstacles. Maximize some reward function. Task specific. Wait, not so much.
Yeah, this is a tube.
Okay. A model-based approach, generating, evaluating fastest. Okay. Navigate first, fast later. Okay, motion to template. X or Y. Okay, yeah, so you sample the point and then check in that direction the LiDAR. Is an obstacle, is a wrong smallest obstacle. Okay. Good news, the op is a function of smallest. The op is a function of smallest obstacle. Okay. So it means, yeah, so because if the op is smaller than the smallest obstacle, if the op is bigger than the smallest obstacle, like you cannot check it. No, go. They also link to their own different. Yeah. Okay. Oh, okay. Oh, yo, sick.
That's really cool.
Sick.
And it's fucking smooth.
Yeah.
It's not even like stuttering.
That's a GoPro camera, right?
No, it's just a mounted camera on the.
Yeah,
Oh.
let's do this, but better. Like, let's do it in public.
How?
I have a GoPro camera. We can mount it on the.
Over the robot though.
Yo, so cool.
And it's like super fast.
Wait, question. Maybe they speed up the.
Or maybe
I mean, that is one of the tricks that many research robotics people do, like X something. But
So I've done video editing. I can.
no, but I
I
think
think they
it,
definitely do speed up.
but I think it is. Or no, I speed up. I'm sorry.
Oh. Oh, okay, okay.
I'm sorry.
That speed makes more sense.
Yeah, but then I think they only drop. Oh, yeah, curve.
Okay. Okay, that's
Yeah, that's a really good.
So yeah, I think this is. Okay. So you guys want to do anything now or discuss more or
Can we see the code for that?
cool? Cool. Commit main update laser model. Wait, then if they have the clutter thing, they have the paper. No. The Springer. There's no GitHub code. Just now I check their run. It's nothing. Yeah. Motion based tube dot launch. Check a helper. Launch motion tube dot launch. Okay, so for those who are following also, this is the launch file. Tell ROS to launch multiple things at once. So it is also the way where we track what is happening where. Find Echo helper config param, free motion node package, free motion tube.ros. Where is that package? Or is it hidden? Is it config
Sorry,
cross collision
That's
work
the most important thing.
configs? Yeah. Package this pack. Oh wait, how about we sense maybe it is maybe they publish it in the okay. Git lab. Okay. Activity. Okay. Probably didn't see, so yeah. Struct, allocate memory, Cartesian, raw position sensor, poser, generic methods, motion tube to Cartesian coordinates. Okay. Free motion tube, novel planner based on sensor commonly used cost instead of the cost map. Okay, yeah, in the sensor space instead of the cost map. Installation, make install, step, prefix span, node to link, usage. Okay. Structure. Okay, so now we know where to look for. Well, what do you want to inspect? Or sensor space. Sensor space. Create, allocate, deallocate. Sensor space. The method deallocate number of beams. So from the ray position, number of Cartesian to sensor. Cartesian to sensor space. The primitive here is just I think a primitive motion of a unit cycle. It's something that free space activity. Tricycle and so space. Yeah, maybe I think this one cannot understand at the moment. That need to on time, on target, and dig deep into this. Yeah, but then how if we are to improve, or how do we go from here? That's the question. And this is motion 2, then yeah, yeah. So some team is faster than the cool team, but then because they hit the collision, hit the obstacles, then they forfeit the whole thing. Yeah, I think that is, yeah, today is quite productive. You want to call it a day, or it is a good start. I think it is a good start.
But then you
What do you
are
think?
running a VM, is it?
Yeah, at the moment it's running a VM. It's very slow. I'm planning to like just run install directly, because is that because no, there's no because. Yeah, I think I will
Oh, yeah.
try.
Yeah.
I will try to run directly so that it is. Yeah, so if we run directly, then we will have to automate. In a sense, yeah, we also need some scripts to automate the whole process. Yeah, a launch file. This is so tedious.
Would you like to try my experimental routes builder? That's in prototype development. That might crush the system, but if it works, it might save us about 5 minutes of time.
If it crash, it costs us 1 hour.
I'll fix it, it's fine.
Yeah. So, do you have? So you said you have a. You're running on a Jetson, but and the problem is.
Like I just like you remember when you were connecting the topics. I
Yeah.
didn't find what topics.
Oh.
Yeah.
Oh, and it just finished, and then
Yeah, it just finished.
yes, and it just finished. Correct. Yeah. So I think we at the moment we also need a script to automate the whole thing. So at least we don't have to keep looking at this. Yes.
Yes.
The what? Sinpei said
Senpai?
no. A guy called Sinpei.
Oh, so.
He's like
First of all,
Technically a senpai.
yeah, true. That is also true. Yeah, he's doing graduate PhD at the moment. He was also a member of the club, and he just moved on to do PhD in NTU. So last time he was undergrad here. He's also doing robotics, and he said that can use Windows WSL.
I'm doing that.
Okay.
How about the GUI though?
Told you.
Yeah, the GUI is
Scalable.
you can I think it
If
should
they
be
don't GUI, I just use the
Oh,
for
WS.
UI.
oh
Technically, you
right,
only need the command line for it.
all right.
At least you can still got you.
Wait. So if you use WSL, a window will not pop up, is it? You cannot
I think
open.
it's a separate,
It's like you pull the Linux terminal and it just the
Yeah.
terminal.
it cannot access the window.
But then, for example, when I use, let's say, file directory, right? I can use Window Explorer to. So there's
It's another directory, like they simulated the Linux directory.
yes, but then my Window Explorer is still give me a GUI feedback. So does that apply to other GUI related program? Will the Windows like mediate that?
You can technically just open in File Explorer your Linux file.
Wait, what?
Yeah, you
Yeah.
can.
We would need
Yes, but I'm not sure if other GUI Linux program can run.
Oh,
You mean like Azure, like Arby's?
Yeah.
Yeah, it runs.
Oh yeah.
Oh.
Then good. So then Gazebo also run.
Yeah. You just doesn't connect in like and it's my problem.
Then yeah, just now in the run.py, there is this. So if it takes in the GUI, then it will pop out the Gazebo. So in the code,
I'll try to set up.
I also
WSL,
uh,
but maybe have some setting up. Yeah, I not even set up the roles because I'm stuck at the last step.
so I did yeah, I just sent like 1
Oh,
hour
it
ago.
has a YouTube.
Yeah, we do.
I don't know.
And just now I upload the 2 things because I was in the process of installing. Then I said, oh, might as well just video record.
Oh. Okay, that's nice.
Yeah. But so bad.
Maybe I can fix my issue.
Wait, this for Rose.
Yeah. So this is the VM that yeah. Hope you can fix your problem. Okay, let's call it a day. Okay.
Okay, I'm gonna go home to set up on my